Anyone have any doubts? You can ask. So this is, you have to know, kn is a permutation k factorial divided by k minus n factorial. And again, this one, n factorial. Okay. Then we know the equation for the collocation yk is equal to summation I is equal to 0 to k, ki delta I of y naught. So first of all, first question is for the k is equal to 1. So y1, so wherever k, you have to substitute 1. Okay, then it is a summation. So you have to write the terms up to I is equal to 0 to 1. So there are two terms. So this is for I is equal to 0. This is for I is equal to 1. Therefore, you substitute the 1, 0 will be 1 and 1, 1 will be 1 again. Okay. So if you substitute 1 time, this will be delta naught y naught will be 1 y naught itself. Okay. Plus this will be 1 time y delta y naught. So this will be our last answer. So similar way, 2, 4. What is our next question? This question for this y2. So you have to substitute 2 only. See whether you got the answer. This is easy now. Nothing. Just I think the permutation of this one may be 1, this one may be 2, this one will be 1. Okay, all the others are same now. So I'm not going to do that. Okay. See whether you can get the answer. Okay, or you can do as a homework. So let's continue our next polynomial. Okay, the second polynomial we are going to study is factorial polynomial. So what do you mean by factorial? Factorial itself we have seen like this. N factorial means n into n minus 1 up to, you have to go up to 1. Okay. And polynomial itself, you know the definition. Okay. So if it is combinedly having, we call as a polynomial, a factorial polynomial. Okay. So the factorial polynomials are defined in this way. It is like a, so in the collocation polynomial, yk we have seen already. Okay. So you have to keep memorize. Similarly, this is a factorial polynomial. So yk is equal to k to the power n. Okay. Which is equal, this is also one of the notation. K of n. So if it is k, it is k to the power n. Okay. So what is that n? We can see that. Okay. For example, so this goes to, this kn means k into k minus 1 into k minus 2 into, it goes up, if it is n, let's say n, you have to get the polynomial up to k minus n plus 1. It means what? K minus n minus 1. Like this. Okay, then only you'll get k minus n plus 1. Sorry, k minus n plus 1. Is that correct? K minus n plus 1, no? So why? Because they go up to this point. Okay. I'll write again. So this is the equation for the factorial polynomial, which is k minus 1. This is kind of the factorial, no? That's why it named as a factorial polynomial. It goes up to, so if you need k to the power n, you have to go up to n minus 1 term. That's what they have written as a k minus n plus 1. Okay, in a one bracket. If you need two bracket, you can write this way. Okay, where this n is a positive integer. Okay, so hereafter they will ask this part. See, you can see some example. Are you all writing the notes? Okay, let's see some example on it. Okay, for example, if it is K2, okay, K is a 2, K2. So you have to go up to where? So this is for N, you have to go N minus 1. So if it is 2, you have to go up to 1, isn't it? K minus 1. So if you simplify this one, it will be K square minus K, okay? Similarly, if you want K3, you have to go up to 2, isn't it? K minus 1, K minus 2. So what is the formula? So you can multiply 2, no? This will be K squared minus K times K minus 2. This again K cube 2K squared minus K squared plus 2K. The final answer will be K cube minus 3K squared plus 2K. Am I right? Let's check the answer. Is that my answer correct? Why only 87 people? Where's the others? So if you come one meeting and if you go down in the other meeting, it will count as absent. You have to be full lectures. Okay. So try yourself some like this. You can try this one. K to the power 4 what is what? K to the power 5 is what? Okay. So let's do like a homework. Okay. That's nothing. Just for the, memorizations. Okay. Okay. Let's find the general equation anyway. So we can't, every time we can't, multiply this way. No, we have to have some common general formula which can be derived quickly. So that's what we're going to study now. Okay. For the first difference, delta Kn, this is what, if it is Kn, we have n of Kn minus 1. Am I right? Okay, let me see like this. Kn is what? We have to go K minus 1 up to K minus N minus 1. Okay. So it is like, so if it is delta Kn, okay. So what I say for delta, what is the idea of delta? Hmm? Why we use the delta here? Anyone? Did you notice when I say? I told what is the idea of delta here in our this course. Yes, good. One person has noticed. Okay. It's like a difference. It means from earlier yk to yk minus 1, like that. So, or yk plus 1 to yk. Okay. So you can check the formula. So delta Kn, first difference. Okay, delta Kn is can be, you can derive like n of Kn minus 1. It means n times 1 less than this. Okay, n times Kn minus 1 power. So similarly, if you are taking second difference, it will come like n into n minus 1 times K 1 less than this. Okay, n minus 2. Okay. Similarly, delta 3 k of n will be, what is that? You already know the answer now. So we are taking this one down and this. It's like a difference. Okay, differential equation. One power down and power less than 1. Okay, it's like 3. So if you go up to, let's say, lambda n minus 1 kn, what is that? So see the pattern. If it is n minus 1. If it is 2 here, we have two terms here with n minus 2. 2 less than this. This one, we have 3 and n minus 3. This and this. So what do you think? So you go n minus 1, n minus 2, up to where you need to go. See, this is delta 3. You have to go 1 less than that. So 1 less than that is what? N minus 1 minus 1 will be n minus 2. Okay. So you have to go like up to n minus 2 anyway. Okay. Not n minus 2. N minus 1 minus n minus 1. Am I right? Okay, wait. So 3, here 2. Okay. N minus 2. This minus 1 less than that. So it means, okay, I'll take the whiteboard. It will be very easy for me to explain. Let me go this way. So let's see. Delta n we had n k n minus 1. Similarly, the squared kn. See, this like a n, this is like 1, no? So n minus 1 power. And this n come here. Next one, n times n minus 1, k times this minus this. Okay, kn minus 2. Lambda 3 kn. We are finding the pattern, how it goes. So next, n into n minus 1. We have to go 1 less than this, n minus 2, up to k of this minus this, no, n minus 3. So if you go up to, let's say, n minus 1 term, before n, let's find out the n minus 1 term. So you have to go up to n minus 1, n minus 2, up to, see, n minus 3 minus plus 1, isn't it? So it is like a 1 less than this. So n minus 1 less than this, what? N minus 2. So n minus 1 minus 1. So what is the answer? So n minus 1, this will be minus 2 when you are coming plus 2. Okay. So n minus n plus 2. So n cancel out. So you have to go up to 2. Did you get that? Multiply by 2. So what is the final one? So you have to take this minus this, no? So this minus this. What is that? N minus 1. What is the answer? N minus n plus 1. So it will be only k. K1. Okay. So you can put this one nicely like this. Is that correct? Please correct me if I am not. So similarly, if you want to find the delta n power, you have to go n minus 1. It will give you, I hope, it will give you up to 2 and 1 and k of 0. Is that correct? So it is like what? This up to this one, k0 always 1 times, what is this one? There's answers. Okay, so this is our n factorial. So what you are getting is our lambda to the power of n of kn will give you the final answer n factorial. Okay. So this is our final conclusion. Sorry. Okay, so it means lambda n kn will give you the answer n factorial. Okay, this is our final answer. So we can use wherever we need. Okay. I hope you understood. So let's move on to the notes. Okay, that's what they have found here. Okay. So nth difference is delta n kn is equal to n factorial. So if I ask you to derive, you have to derive this one. Okay. Sometimes derive, if the question is like this, derive lambda n kn is equal to n factorial using the factorial polynomial formula. So you can answer what I have done now. Okay. So you have to write the formula of what is factorial polynomial, then what is delta kn, and this and that. Okay. So this will be the question, this will be the answer. So I gave the question also. So when you're studying, you study in that way. Okay, let's continue. We have some 20 minutes there, so we can finish up these two polynomials today. Next one is called as, let's see one definition, it's called as a Stirling numbers. Okay. So put the heading Stirling numbers. So let's see what it means. Okay, we're gonna study two kind of Stirling numbers. Stirling number of the first kind. So what the Stirling number use is, which is, you can write here, which is appear, this kind of number system can be appear when factorial polynomials are expressed in standard polynomial. Okay, standard polynomial. Okay, as we know, we have yk is equal to k to the power n. This is our factorial. I mean, factorial polynomial. But actually, our normal polynomial is a0 plus a1x plus a2x. So in that sense, so we use this Stirling number systems to write our factorial polynomial in a standard polynomial way. Okay. So let's see what it is. So the Stirling numbers of the first kind. Similarly, we're going to see the second kind also. So the first kind says the kn can be written in this way. So kn we have used for the factorial polynomial now. So kn can be written as s1 n of k plus s2 n of k2 I think power cut, so kn. Can you hear me?